welcome to yet another webinar in now the Iliad Hackathon webinar series, where we are going through several of the results and tools that we are using and creating in Iliad. Today, the topic is the ocean information model, and we focus on practical use. And with me, I have a panel of super experts, and I'm really looking forward to learn more in detail how we can use and continue to develop the ocean information model. My name is Bente Liljaby. I am the owner of BLB, a company residing in Norway. I'm one of the partners in Iliad, dedicating my time to data management and open data. So I'm all excited, and just to go quickly through the program, first we will get a practical introduction to the ocean information model by Raul Palma. Then we jump to APIs, semantically enabled APIs for the ocean information model with Piotr Zaborowski and Alejandro Villar Fernandez. Both of them are from OGC. And we have an example also to show you, the jellyfish examples by Dori Edelist. And then we jump to more step-by-step, first steps on the data harmonization process using ocean information model by both Raul Palma and Francisco Martino Recuerda from Sintef Digital. So that is the program. So let us just start and get some practical introduction to the ocean information model. Raul, are you ready?
Yes, I will now share my screen then. Okay. You see full mode?
Yes.
Okay. Great. So I will go just to the practical usage of the ocean information model. So I will not go into details of the model because we have already provided this information in the past. I'm just putting this as a reminder, like a high-level view of the model itself, which is basically design and architecture in a layer way with different modules at the different modular level. So we have some elements at the higher level, which are the cross-domain and of course the meta model layers. Then we have elements at the domain, the ocean domain, and then we have a specific extensions for pilots. Additionally, the model has a metadata layer, and it also makes some connections to different vocabularies that are available. One of the most important aspects of the ocean information model, if you remember, is the reuse of existing existing models. So instead of doing something from scratch, we are leveraging what is already available and aligning all of these different models in a coherent way. So just here, important with respect to the alignment with vocabularies, just to mention here in terms of Iliad, the most important ones are coming from worms, which is the list of name of marine organisms. We also have essential variables, which are defining observable properties in different domains like biodiversity, climate, and others, but also the climate and forecast variables, which are also being used in many different places of the pilots in Iliad. And we can also make connections to AgroBook concepts. So how it looks when we are representing data according to the ocean information model. So I'm putting here a few examples. This is coming from the jellyfish, how the information that we are collecting from the data sources is being represented in the ocean information model. So basically, in our cases, we have, for example, defined some collections of observations, because these are observation of jellyfish. And then, of course, we associate according to this to our models, which is based on the SOSA SSN, which is one of the most relevant from the OGC and W3C standards. So we can associate the procedures, the sensors associated making these observations, the observable property, the future of interest, and of course, the individual results. So obviously, since we are having here collections, we have then individual observations. Each of these observations has a specific result. So this is just to give you an idea how the representation of the jellyfish looks like. And similar with another example from oil spills pilot from Iliad. So here you have also a collection of observations for some trajectory. And then you have the sensors, the procedure, the feature of interest, and the result time. Everything is shared by all of the different observations. And then the individual observations are just saying specifically the value, I mean, the simple result, and what was the observed property. So obviously there are some properties that you can see that you can associate at the level of the observation or at the level of the collection, because this is like the potential way of representing properties that are shared across many observations, but these are coming at the end into some kind of harmonized model and structure, which is based on the SOSA SSN standard. So how to use it in practice? The OIM, basically you can start, of course, finding terms and retrieving annotations. To start, for now, the ontology and the model itself is available in the biodiversity portal. So you can find the ocean information model there. From there, you could get annotations from your particular data set. So for example, to get some examples of the different terms that you could reuse from the ocean information model. Obviously, this will not be the only place where the model will be. We are putting all the pipelines in the OGC Rainbow server to make it available as well from there. And the idea is so you are able to navigate, browse the different taxonomy of terms, and also identify what are the terms that are relevant for your data. Obviously, you could use directly ocean information model in your services. In order to do that, we are particularly focused on services that are exposing REST APIs, and in that case, some JSON with some JSON payloads. So we are basically saying, okay, so continue to use JSON, just add the semantics, add the connection to the ocean information model, and this is done by using JSON LD. I will show you in a second how it looks like. And then once you have done that, you can validate that the data is compliant with the ocean information model. You can do it at the syntactic level and making sure that all the terms are coming from the ocean information model. But then you could also use in the future something that we call the shape forms that will allow you to validate data at the semantic level. So in general, that's how using JSON LD with ocean information would look like. So basically, the context in the JSON LD, I mean, the main difference between JSON LD and JSON for developers is that you associate a context to the payload of the JSON. This is associating basically the terms in the JSON file to elements in the ontology, elements in the ocean information model. So in this case, the context needs to be defined and include the ocean information context as reference. This is like the one that you can see here. This is, of course, very small subset of the context of the ocean information model. And then once you have done that, you can start defining elements like here. This is not coming directly from the ocean information model. This is another example from another information model, but this is how it looks like, because we don't have now like REST APIs examples for the ocean information model, but that's how it looks like. So you have the context defined at the beginning, and then you start defining the terms that are coming from the context. So that's, how you start working with that. Of course, we provided the supporting tools to help you to do the harmonization of data sets that are coming also from static sources or mostly static sources, or that you are collecting periodically, to sources that are coming from more streamlined. So you have different tools and services available. So from the command line tool to web service to some kind of simple user interfaces to do this kind of harmonization process, and also how to do it on the fly, doing this kind of virtual semantic layer on top of relational databases or RESTful APIs. But the most important at the end is how you specify the mappings. Of course, how you map the terms in your source to map to terms in the ocean information model. Obviously, you can start with some kind of conceptual mapping that you put, for example, in a spreadsheet. Then how these mapping are represented can be done in different ways. It can be done, for example, as queries. This can be done as YAML. Of course, can be done as RDF, but also CSV, WW. There are many different ways how you can represent the mappings. And this is something that we have, like the tools give you some examples how to do that, but we can also, of course, help you in the process of specifying these mappings for your different examples and scenarios. So the last step, once you have the data harmonized, is how to make it accessible via some standard APIs. Obviously, you can create your own API, of course, but it's also ideal if you could expose the data via some standard APIs, and these are coming from OGC, for example. We are relying a lot on this. OGC have already created and specified several of them. So this is something that we are trying to leverage, and how to create all of these mappings also is one of the possibilities that we can do automatically by the harmonization tools that we are bringing into Iliad for you. So at the end of the day, you have different interfaces to access the data. You can use queries, you can use faceted browsers, you can use custom APIs, you can use OGC APIs or web client applications. And I'm just showing you here some examples of these interfaces, how it looks. These are the faceted searches or MetaFactory application to navigate the data that is harmonized. These are Sensor Things API generated automatically from harmonized data. And these are web interfaces that probably Dori will come a little bit more in details, because this is coming from the jellyfish example. So with that, I just finish here. Of course, I hope to get some questions from you later on.
Thank you very much, Raul. And I'm sure you will share your slides so that people can revisit when they are again looking at this as a video, when they really want to dive into the OIM, or Ocean Information Model. So we will come back to you later, of course. We're moving on in the very dense program we have. We are going now to APIs. Semantically enable APIs for the Ocean Information Model. And I don't know which one of you, Piotr or Alejandro, will take the floor on this.
I think I'll go first, and then leave Piotr.
Yes.
Go ahead.
Thank you.
Okay. So let me just find.
So while Alejandro, I forgot to mention who you are a little bit. So you are an expert on linked open data and semantic webs, and of course you are working at the Open Geospatial Consortium, OGC, as a colleague of Piotr.
That's absolutely right. Thank you. So I don't know if I can. Okay. Can you see the slideshow?
Perfect.
Okay. So thank you, Bente. We're going to talk a bit about what's the value proposition, what do we get by using these open standards, these standardized APIs, semantics, and in short, what do we get out of using the Ocean Information Model? So the main issue behind interoperability in general can be illustrated by the following problem, right? You have a consumer, for example, researcher on marine biodiversity, that needs to retrieve data from different sources for whatever purposes. This could be to create a study, an early warning system, to guide policy makers to enact new legislation, whatever the reason. So this consumer first needs to figure out how to access the data. For example, if we wanted to retrieve data from Spain, Poland, and Ireland, we're talking about 3 different countries with different governments, different types of potential ways that this data could be offered or served. We could be dealing with open standards. We could be dealing with proprietary products for serving this data. So what's in our opinion, in the opinion of the OGC, what's the way forward for this? To use standard APIs, right? The standard access mechanisms to retrieve the data. The OGC publishes different types of APIs depending on the type of data that is being served or retrieved in this case. We can have APIs that allow users to access data on specific observations. They can access raster data spanning different spatial and temporal coverages, etc. So this is the first step towards semantic interoperability, which is data access interoperability. The fact that now the client, the consumer, the researcher can actually find which data is available and retrieve that data. But then comes issue number 2, right? We're dealing with 3 different data from 3 different countries, 3 different countries with different languages, different traditions even, right? So sorry, just to get this out of the way. So for example, once our researcher retrieves data, in this case, JSON data, right? From those 3 different countries, they encountered these results, right? They encountered that in Spain, they have profundidad. In Polish, I'm not even going to attempt to pronounce that. And in English, they have depth. And even though they're representing the same thing, we have 3 different values for this, right? So there's the issue of how would these researchers go about harmonizing all of that? How would they, if they want to use the data from those 3 different sources in the same study, in the same product, how does it all get combined, right? Merged in the same space. We have the concept of harmonizing the properties, the dimensions, and even the units, which is one of the cases in here. And then I'll talk about it about this a little later. We have the concepts and control vocabularies. The fact that not only are we going to encounter literal values, right, like numbers or character strings such as the name of a person, but we're also going to have different types of properties that have a set of values that are allowed. So what can we do with linked data, with semantic data? What we can do is we can associate, we can bind these different properties to a shared property within the domain, right? Within the knowledge domain. So in this case, for example, we have this property here, which is part of the ocean information model, by the way. It's coming from the climate and forecast variables. Those familiar with NetCDF are probably also familiar with the CF variables. So when our data is in semantic format, a consumer, instead of having to deal with these 3 different definitions for the same concept, they can say, oh, this is, we're talking about depth. So I know how to deal with depth. I know how to combine, how to merge these 3 objects. But also, we can annotate the values by specifying the unit in a standardized manner. For example, we have meters in the first case, centimeters in the second, and feet in the third case. These are all coming from the QDT vocabulary, which is a collection of units of measure and of measurable properties. It's very comprehensive, and it's also part of the ocean information model. And even when we're dealing with the same language, there are some issues that can also arise. For example, imagine that we had data from 2 different sources and both have age as one of the columns in one of the properties. One would assume that the age is basically a number that specifies the number of years that have spent since the birth or the creation of whatever object we're dealing with, right? But that may be true in one case, but not in the other. We may be dealing with the age of a person in one case, and with a geological, right, age in the other, a geochronological era, right, so to speak. And in the case of geochronological eras, in the case of geological ages, we have control vocabularies. Not everything is allowed. By using semantic data, we can have we can make the distinction between those two things. We can resolve these ambiguities so that we have a vocabulary for the age of a person, and we have a vocabulary for specifying the age of a geological age. And we also have terms. These are not part of this is just merely an example, but this is not part of the ocean information model, but we have terms for that control vocabulary as well. For example, DBpedia, which is a semantic version of Wikipedia, has terms for this. And we also get a few additional advantages. For example, since we're using the OIM as a common information model, we have a vast amount of properties and control vocabularies that we can use for these domain-specific data. We can infer new relationships from those relationships that are already present in the ocean information model, and with which the ocean information model can be also enriched. And we can work with profiles, different types, different views, perspectives of the data, depending on what the consumer is interested in. We can, and I think Raul is going to show examples of this later on, we can convert linked data to many other different formats and even create full APIs on the fly. And if we're working, and this I find very interesting, if we work with semantically enabled data catalogs, we can not only federate different catalogs coming from different sources in different formats, but we can also enable customers, clients, consumers to perform the advanced queries, right? To enhance the find all infer, right? For example, we could launch a query to find all data sets with measurements of seawater temperature from whatever year to whatever year, and with constraints on the types of uses that can be done from a copyright standpoint, and so on. So with this, I'll pass the baton to Piotr.
Thank you very much, Alejandro. Are you sharing the same presentation or no? Piotr, you will...
Yeah, Piotr's taking over.
Having your own. So Piotr is leading and managing OGC Collaborative Solutions and Innovation Program, and has a long experience, a vast experience on everything standards. Piotr, I give you this very short introduction. Many of you here already knows Piotr. Piotr, you are ready? No, it's still Alejandro. Can you have to unshare perhaps, Alejandro?
No, I'm seeing Piotr's screen.
Oh, okay. Okay, yes, I do too.
I think
If
he's
you are
just muted.
Yes.
Thanks. Thanks for this introduction. I will go through several tools, but I guess the idea is just to let's say initiate this discussion, and we are collecting also some of these examples I will show in this repository, which is the Iliad Ocean Twin, and there are several like Ocean Information Model and Data Access API for description of these cases. You can always come back to that. So, as Raul mentioned, the Ocean Information Model is partly based on the OGC ontologies for SOSA, but also for this geospatial information. And based on that, we can maybe claim that if you are conformed to the standards like OGC, or you're providing the data in the CF convention in your storage, you are maybe half through already with this Ocean Information Model integration. So I will just show you the use cases of the application in the API exposed data, and based on this reference implementation of the recent OGC APIs, I will show you a few things. One is that all of the APIs are sharing the same concept, that there's a landing page you can browse through, and you can click through several links to follow the metadata, but also to access the data. It's also providing the documentation, which is automatically generated based on your data, which means if you are a developer, you can easily read this and you can find out that, for example, for these observations, you can narrow down your query with several properties. If you want to select the items, you will simply have several properties like the bounding box, which is kind of specific to a case for the geospatial information when you query the data. But then it provides you also this. Yeah, I need to go back. As mentioned, to all of the collections. So the modern API are actually based on this principle. You have all the collections that can be put together one by the other, and you can navigate through them easily. And so you can discover what's in the data as human being through this HTML interface, or as the machine through this JSON interface. And you can also discover some of the high-level metadata, like what's your coverage of the data in space and time. And also sometimes if that's exposed through particular APIs, you have also the properties which are shared in these data sets. For example, in this data set, we are seeing that there is something somebody called HS, and there's a description. Okay, there's sea surface wave significant height, but actually we don't know what does it mean. We can have some units here, which is already good. We have unit of measurement, which is meter, but how this data was performed, is it conformal to any standard, is the other question. And we can through these APIs, we can easily access the data. We don't have to download the whole file. In the backend, there is an netcdf file for this case, or the storage of the netcdf files we are getting as collections, and each of the collection has the same capability that you can query that with the APIs. So here are the examples of the links you can use, but naturally you can modify them as you will, and you will get the data from the particular regions you want to have. So for example, we are changing that to the some different coordinates, and then we will get some other data in this case. See that the data is a little bit broken, but we see already some specific measurements are here provided with the legend. And under the hood is actually JSON, so meaning that this HTML interface is based on the open source tool plugin to Leaflet, which is converting this JSON into this visualization. And the JSON, yeah, the link is not here. The link is actually here. You can get the same information in the JSON. And actually, you can get the same information if you want in some other. Yeah, how can I move this around? And in the formats that are supported. So this API is supporting netcdf and ZAR, for example. So if we would change the in the link the JSON to netcdf, we'll get this data. And that's thanks to just setting up the SpyGeo on top of the storage. You have harmonized, at least initially, to these conventions, which are describing how the data is organized in the multi-dimensional storages. But we can also have different types, as Alejandro mentioned. This was coverage. We have also the observations, which we just took this CSV file with all of the observations, put it in the in this tools, and we have already the interface that provides you the ability to crawl them and to actually navigate through them as you want. You can also navigate through this web interface like browser, but you can also navigate through JSON. And yes, you can query that with also bounding box and time, and all of the parameters are here are actually queryable, so you can easily discover what parameters you can query with. So if you want only some of them exposed, you can easily get them. But still, there is a question like, what are those? Like, what's the scientific name, vocabulary that is used in this interface? And even if we get to the well-known tools like these QGIS, I just added here the, you will see this is actually the same connection. I'm using my own server, which I was just now in the web interface. I can connect to that, and as I move this windows of this here, I get the same information that is in the web interface. So the standards are for that case, providing us this harmonized way you can navigate through your data, whatever tool is actually useful. So in the examples in the GitHub, I have also examples of the Python script in the Jupyter notebook, which is accessing the data through these cases, and we can naturally query this data, and we can read all of that in our tools of preference. But still, you see, we have just the minimum compliance. We still don't know what are the properties defined here. And we are solving that quite nicely with this JSON LD representation, meaning that you see that there is a JSON representation of all of these observations. Yeah, you see there's metadata on the catalog level. You will see also the metadata on the item level. Each of this is actually a GeoJSON feature with set of properties. So what we add to that is actually just the context that Raoul has mentioned. There are contexts which are defined for generic cases, like simply features or observations, but it can be also profiled to protected areas or any other vector data in this case. And we have linked to these vocabularies that are automatically generated from the ocean information model. And we are not changing anything else. Yeah, so you see that the data is actually the same. We've just added type of the feature, but that's not required. That's just helpful to do the same stuff as in the SensorThink API. And we can also check if that's actually semantic data. Semantic data means we have all of them provided with the definition. So in the payload, we just see the scientific name, but actually the scientific name is linked to the definition, which is coming from the WC, and we see that all of these terms which are used from the ocean information model. So you will see also in this easier interface that we have also resolved the IDs of these species and the names of the species in here. We can go through to that directly and read what's the definition. And we have also been provided with this generic templates with the valid interpretation of the coordinates. And that's important because coordinates are important in the geospatial information. We have many coordinate systems. And even if we are talking about the marine, which is covering the global ocean, in the particular cases of your local data, you need to merge that with your other sources of data which are provided simply in different coordinate systems. And you need to understand what is the reference for that. And yeah, I think that is enough for the moment. And I just point you out again to the repositories where actually we are collecting the issues. If you have any issues with implementing that, feel free to create simply an issue and we'll try to respond.
Yes, thank you very much, Piotr. And so your slide deck will also be made available, but both you, Raoul, and I think also Alejandro and Piotr, you have mentioned some links. Perhaps you would be able to share some of the key links in the chat here for the people that want to explore a little bit. But other than that, I think that we have to have some time to sit peace and quietly and explore this, but just a few key links would be good to have in the chat.
Yep.
So thank you very much, Piotr, Alejandro, and now we are moving on to Dori Edelist. He is verifiable, enthusiastic marine ecologist. He's a researcher and teacher at University of Haifa, and very much interested in jellyfish. So, Dor, the floor is yours. So, just a kind reminder to mute yourself if you are not speaking, and then you're unmuted, Dor.
Thank you, Bente. So I've been dealing with jellyfish for about 15 years now. And in the past 3 years with the Iliad project, we've taken our data that comes from citizen science, that comes from citizens, into a new level, really, of standardization and semantic analysis, and really getting it in line with some bigger program. And for me, it was a very exciting process. So we'll take you real quick through what we're going to see now, which is starting with citizen science with our sensors who are human, the life cycle of the data. Some stuff will be a bit repetitive, and then standardization, creating the ontology using semantic analysis, and finally bringing it in back to the OIM and how we can use the jellyfish data to showcase how standardizing data and bringing it in through the pipeline can be used by multitude of agents and actors even outside of Iliad. So first of all, jellyfish. Jellyfish are a win-win for citizen science, which makes my sensors, the citizens of the coasts of Israel, really good at what they do. They sting, they create other hazards, they block desalination and power plant intakes, and really we see a lot of interest from the public. Right now, as we're speaking, there is a swarm of jellyfish that is making its way towards the coast of Israel. It has already started arriving, and we see a peak in reporting. And those are things that we need to consider when we build the data infrastructure, that you will be getting summer peaks in reporting, for example. So these are the coasts of Israel that we've already seen, and these are our sensors. They do multiple marine activities and coastal activities as they are surveying the environment for jellyfish. And getting these different sources of data requires, for example, in the semantic analysis that we'll see later, a new term for what my sensor is doing at the time of taking the observation, whether they are swimming and have their eyes in the water, or whether they are walking on the beach, whether they are yachting or scuba diving, and we're getting different perspectives. Also, the level of training is different from one person to another. So we'll use what we call gold users, who are trained citizens or marine biologists who are already familiar with jellyfish species and are already familiar with our app and have been trained by us to attain a higher level of certainty of the data. So the data goes into a web app called Medusot, and then we pre-process the data. We validate it once daily and once periodically to create a jellyfish map. And the data also undergoes standardization and through the terms in the ontology that we have developed into an OGC API, sensor things, and finally into visualization stage. In the background, of course, we have a database that is being accumulated that can and should contribute much to the study of jellyfish, not only locally, but worldwide, because once we put the data through this pipeline, then we know that it could go into EMODNet, it could go into GBIF, OBIS, and any other globally recognized data set, and used also in global meta-analysis. So back to the local, just to show you the utility, we've had a swarm of salps that were observed. You can see them on the left-hand side with a nice kid in there, sort of crushing them between her hands. The salps are non-stinging, but they do feel the ocean. They cause a lot of havoc in desalination and power plants, and we were able to use this to actually forewarn them that salps are coming. Similar thing we did with jellyfish. We do it every summer. We look at jellyfish swarms. Once they intensify, we let the public know. And that is also one of the ways that we can attract people to report in the data and to join this jellyfish joyride with us, to really take part in becoming gold users and becoming also, we turn, as Piotr and Alejandro mentioned before, we take the data and turn it into knowledge. So we can basically revert the data back to them. And that cycle in citizen science is extremely important. So we take the input, we pre-process. Sometimes people would press send a lot of times and we would get duplicates. Sometimes there will be errors. Sometimes there will be internet trolls or things that harm the data. So we pre-process it, we validate it, some of it manually, some of it semi-automatically. Already by now, we've done this for a while now and it works okay. And then we turn to building the ontology. We looked at different terms, also using SemFlow that Ramani helped us build. And just looking at the different terms, we start with the OBIS, which is the largest marine repository for biodiversity in the oceans. And they have Darwin Core terms, that's the DWC, which is the standard for biodiversity reporting. And you can see these are must-have terms. These 8 terms are required: occurrence ID, etc. And on top of these, we added some elements that we consider as vital for the JOIS and are also in the Darwin Core terms that can be found. For example, if we're talking about photos or videos that were taken, then they can be entered as well under machine observation. Organism quantity is actually the one that we've had the most problems with, because it seems trivial that, all right, either we have few or we have a lot or we have none. But if you try counting jellyfish, that is an insurmountable challenge, sometimes even for scientists, because the sea is extremely large. Jellyfish swarms are always very, very patchy and non-uniform. They move with the currents. So that is always going to be a big challenge. And we gravitate back to the lowest common denominator. You can see swarm, some, few, or none. And we have some definitions for what constitutes as a jellyfish swarm, which merits a lot of discussion, but not right now. So, and there are the specific jellyfish reporting terms. For example, we've spoken about the activity that is being performed, but also jellyfish are often stranded on the beach. This could also happen to whales, for example, but it's much more common in jellyfish, and thank God for that. And we can create our own terms from that using something called EMOF within Darwin Core. Jellyfish also sting, as we mentioned. So if the person got stung, that is also vital information so that we can tell whether certain species of jellyfish are in charge of more stinging than others in the data analysis later. Right, this is where we bring it back to the OIM. All of this data, as it is standardized and harmonized, as Raul mentioned before, flows into the OIM via the pipeline and through the Jellyfish Pilot OGC sensor things API that we've seen before also. And eventually gets fed into the OIM. And the nice addition that we got from this is that analysis and visualization. For example, on the left-hand side, you can see the jellyfish species, the different species. On the right-hand side, you can see jellyfish reports grouped by activity that we've already mentioned. So you're going to have a lot of, for example, a lot of jellyfish in July. This is, for example, for which year? I think this is, this could be 2022. So we've had a lot of jellyfish in July, for example, and a lot of reports, and you can see what the different people were doing at the time. So we get this, and we get the jellyfish map that we've showed you before. For us, it's been a great ride, and we'd like to take others, colleagues of ours, along for this ride. We've started work with 12 other organizations that work like us on quantifying jellyfish and monitoring them and alerting the public across the Mediterranean. And from some of them, we've already gotten data sets. So if we could take these data sets and have at least some of them harmonized in the same way and put through the pipeline into the OIM, then we've done something nice here. and beyond the scope of Iliad even. And hopefully this will live after the project and start a movement, a motion of something big towards standardization and interoperability, really, which is the end goal of the entire thing. We're talking about fair data that is really important in citizen science. It has to be findable, accountable, interoperable, and reusable. And this is basically what we are doing. That's the gist of it. So thank you for your attention.
Thank you very much, Dory. It's indeed a very inspiring and interesting project and example of the use of ocean information model. So now we are going back to a more step-by-step instructions, I believe. I don't know which one of you, so we have first steps on the data harmonization process using ocean information model. You saw an example from Dory here, and now we are going a little bit more practical again. I think Raul and Francisco, I don't know which one of you will go first.
I think that we will just go, so it will be all together.
All together, okay.
We will try to synchronize. So the thing is that the idea of the last part of this webinar was to people eager to try on the ocean information model. They might be wondering how I can start basically doing the harmonization process. So we wanted just for all the one who wanted to try, give you the first step that basically you need to accomplish. And the first step you need to accomplish is just basically to make a selection of the terminology that you have in your data set. So basically create a small data dictionary where actually you represent a list of the terms that basically you are using in your data set. That could be actually, for instance, column names, or can be, for instance, specific values. Like, for instance, if you are using a specific unit of measure, you wanted just to select this unit of measure as a part of the vocabulary that you are aiming to harmonize using the ocean information model, and create a simple Excel table with just these lists of mappings. So this list of equivalences. So Raul, shall I share, or you will share the Excel file?
Yeah, okay, I can. Well, if you want, you can do it, Francisco. It's fine. I put it also in the GitHub. Yes.
Fantastic. Then I just basically, let's see if I can. Yeah, here you are. Okay, I think you can see it, right?
Yes.
Yeah, so this is basically the mapping table that was created for the jellyfish pilot that was presented just before. So in the jellyfish, they have in the column A, you can see a list of terms that basically are used in the data set that the jellyfish is generating. And then you have also, in addition to the name of the term, also if there is of any type, like a string, integer, or it's a URL, you can just see here. And then basically, after you do the exercise of making a selection like this one, so basically preparing this thing, the next step will be actually to explore in one of the available portals, like for instance, the biodiversity portal, which terms in the ocean information model looks similar, right? So for instance, we are looking, for instance, into decimal longitude that is defined in the jellyfish data set. These have several equivalences in the ocean information model that can be used, like these terms that basically we are listing here. In case that people are not familiar, when you see something like SOSA and double colon, and you see DCT and double colon, this is actually referred to a prefix that basically means this is the part of a long URI, but in order for readability purpose, basically we are using the prefixes. And here, for instance, is the term a scientific name, which is an stream in the jellyfish. These have an equivalences in double core, that is doubling core, that is basically a scientific name. So this is basically the process or the first step you need to complete in order to progress in the harmonization of your data using the ocean information model.
Yeah,
So-
I want maybe to comment a little bit on this. So obviously, as a user or pilot or data provider, you don't need really to know at this point, from which vocabulary these terms are coming from, like this WLC or SOSA. This is not relevant at the moment. The important thing is you have the ocean information model context. The context gives you like really the list of terms that are available from the ocean information model. That's very simple source that you can just visualize it, because this is like a simple list or a JSON list of terms. I will put the link in the chat just to where is the for everybody? Geez. A meeting group chat. Yeah, here. Yeah, so this is like the first thing. Once also the on the information model is loaded completely into the biodiversity portal mentioned by Francisco, you will also be able to simply put like the list of extracted terms from your source. For example, imagine this thing that Francisco was showing you now. These are the terms that are referring to the column names in the Excel or CSV file generated by the jellyfish pilot. So these terms is the one that we are trying to map into the ocean information model. So when the ontology loaded into this biodiversity portal, you would be able to get this kind of recommended terms from the ocean information model very easily directly from there. Now, the point, of course, is this process is it takes a bit of time, I would say. Of course, you can also have some support and questions, and especially, for example, there are many cases where you say, okay, but this term doesn't exist, right? So these kind of mapping simple tools that you can get now are doing not necessarily like a contextual similarity check or something like this. So it's more at the level of the syntactic description of the term. So basically what you can also see, as I said, is go through the the terms from the ocean information model and see if this if you see something that is suitable. And then of course you can come to us with some questions. And at the end as well, remember that not everything needs to be covered. I mean, it's not necessarily everything, of course, is already covered by the ocean information model. And that's why we have this modular approach and layered approach, because each of the pilots or each of the application, let's say, might need to have specific terms that are not necessarily in the whole common ocean information model. So you could define all these additional terms that you are needed in your pilot in a way that is compliant with the rest of the ocean information model. Yeah, that's just to complement what Francisco was saying.
So I think that from our side, I think that is was basically what we wanted just to show, just to encourage participants on today's webinar or people who watch the video later. That is, they wanted just to try out. We will be happy to help. And this is the first step that they need to complete. And in future seminars, webinars, we will basically discuss specific questions the participants might have, and we will try to provide the specific feedback. So basically to help them completing the process.
Yes, excellent. So I collected the links that you have provided in the chat here in our webinar planning document, so that we can provide it also on the Iliad Hackathon page. So afterwards now, if you want to revisit, we will publish the recording of this webinar also on the Iliad Hackathon page. And then you will also be able to see, get access to the presentations, so you can study them, as I said, in peace and quiet. And then, as Francisco was bringing up here, you need to have to help, to have somebody to ask when you have a question for it. And we have several ways of doing that. One thing is, of course, to write the experts here an email. So please provide your email in the chat for those who are, that they want to ask you questions. Other than that, we will also have these teams in the hackathon where we are addressing interoperability, where ocean information model will be one of the things that we are doing. And for those of you who are participating in these teams, you will be able to ask directly also, of course, our experts on that. Other than that, yeah, write to the experts. And if we find out, Francisco, I hope you agree with me on this, that if we find out that there are some common questions, that we might actually publish some answers and maybe even bring up yet another webinar. I will be happy to do that as part of the hackathon. If we discover that there are certain issues that we need to address that are common interest, we can do it in a webinar to answer several questions in one go.
That sounds very good.
Yeah. So do we have any questions right now? So please, you can raise your hand. Yeah, Dimitri?
That he cannot open the link I pasted
sorry
there.
for
Can you
it.
please check if?
Yeah.
Can you please check? Somebody else. I think the link was correct. Let me see.
On GitHub?
Yeah.
Yeah, I can open it.
Yeah.
No specific one term.
I also.
About concentration.
Okay,
A specific part of the document, Dimitri.
Yeah, totally. Just one term. Specific part.
Okay. Yeah, of course. Not all the terms in the ontology in the context are resolvable because this is, like I said, based on existing vocabularies and ontologies, and not all of them are resolving. But that's like a little bit beyond the OIM. OIM is just reusing what is there. Okay, but our plan, in fact, would be at some point to put everything in the Rainbow server that was mentioned by Piotr and Alejandro.
Okay, thank you for explanation.
Any other questions? Don't be shy. No question is stupid, remember? It was a lot of information in this presentation, huh? It was, and as a tutorial, I mean, it was like a first step to get an overview of the more practical. We have another webinar which is recorded and that you can revisit, that gives you a contextual, I will say, Raul, are you agreeing, of the ocean information model? Now we were diving a little bit deeper into it, but not yet very like you can follow, click on that and do that. It's not on that level yet, but we are getting there. We want you to be able to use it and to contribute. But I think you have to have some background. Could you say a few words about perhaps what skills or knowledge would be necessary to be able to work on this? Have you some idea? Sorry to put you on your spot here, but do you have to be a super expert?
Is it the question to the audience or?
It's to you, the experts. It's to you. It's to you, Francisco, Dori, Raul.
Well, I think we sit here with slightly different hats. It might take a combination of us. But I feel like when I'm in good hands, my role in it is pretty well defined.
Yeah, so are you a programmer? Just to, do you need to be a programmer?
I'm not a programmer. So
Voilà.
so there you go. So for me, it's first time I'm not getting my hands dirty in coding, but I am looking at it for the first time in my life, and most of the time I understand it. So surely for someone who's a programmer, this will be I don't know if a breeze, but something that is certainly doable. It's probably not a question for me though.
Yes, it is. It is absolutely. I think that was a very encouraging and a good point. That
It's like speaking a new language. Sometimes you understand it before you can speak it or write it. So, yeah.
As far as I understand, I'm not a coder either. But what I understand is that you need actually to have subject knowledge to be able to develop and contribute to the ocean information model. So some are experts on standards, core standards, but those people are not familiar with the jellyfish expertise or ocean expertise for that matter. So you need actually a plethora of expertise and skills to be able to develop this ocean information model to the level we want, right, Raul? It looks like you are nodding.
Yeah, of course. I mean, definitely. I mean, everything that we are trying to do here is also talking a little bit with the domain experts, because we don't, I mean, we are semantic experts, well, some of us, and we don't know much about the domain itself. And talking with the people dealing with such a domain is that we first of all gather, okay, so maybe these are the kind of things that are relevant for coming from these vocabularies, from these ontologies, which are the most commonly used in these domains and so on. But yeah, it's definitely having different perspectives.
Yeah.
Right.
But what I think is important here in this exercise is that, yes, this is the work that is being done between these domain experts and semantic experts or geospatial ones. And once it's done, it's opening the new possibilities and really opportunities, because now the data is like harmonized, and you can be in from different domain, but you can still refer to those linked data approach, and you can find the definitions, and you don't need to study 500 pages specifications of the data before you look into that. And if you are really the application developers, you get at hand what you need. You have the API definition, you have all of the description of the data somehow linked in the internet, but that's the way we are going.
Yes. The reason why I'm asking is not hopefully not making people too discouraged, because it was a lot of code swirling across the screen right now. But even I, who are not coding myself, I understood, the structure, I understand the structure, I understand the concept that you actually have to have. Also, you mentioned an important thing, Piotr, geospatial, because a data expert is not necessarily an expert in geospatial data, that I've learned. So you have to have this this combination. And no one, well, a few has, of course, a very nice overview. I think both many of the people here that presented here actually do have a good overview, not only of their specific niche, but as was pointed out, that we need all expertise, and it's possible to communicate actually with each other to make something meaningful out of this. I wanted to, since we are in a hackathon, I want to speak also to those who are not really coders, that this can be an interesting project to be a part of, a work to be a part of. Yes.
We agree that Raul is already providing a very nice interface. You can decode your data, and really it's worth to work on the cases. And I guess we are all here to help with this implementation. So I don't think that's really required to have deep knowledge in the beginning.
No. So now you don't need to have deep knowledge. So, it can be
at one domain you need to have.
Yes.
Probably, but So it
And an
helps.
interest and willingness to learn new stuff. So I don't see any more questions. Please, you have now this beautiful opportunity to ask the experts directly. Nobody want to ask a question?
Maybe everything was clear.
Yes, probably. Crystal clear.
Also, one another point is just remember that, well, it depends on, of course, the particular situation of each of the pilots, use cases of the people here that are with us or that will be part of the hackathon in general. Because at some points, for example, some people are really just gonna come here as developer, for example, of APIs of their services that they want to make compliant with Iliad. In other cases, there will be more like, you know, this kind of domain specialists like Dory that are coming with data that is being collected, you know, in their initiatives, and they want to make it compliant with Iliad. So, you know, there are different potential ways of coming into this. As a data provider, Dory gave like the perfect example because he has been with us from the very beginning. He explained the journey. As a developer of a product, platform or service, whatever, you know, the most important thing for you, because you are a developer, is like get a little bit on the hands regarding the use of JSON LD, which we were talking a lot since my presentation, and then, you know, Alejandro and Piotr were showing a lot, just, you know, how to include the connections to the ocean information model in your JSON. That's what you need, you know, to think about.
Okay. I think we are 10 minutes past the hour. If there are no more questions or no more comments from you, the presenters, Francisco, Dory, Piotr, Alejandro, and of course you, Raul, just had the floor. We are all happy to start to get our hands dirty on the ocean information model.
Yeah.
Yep. Very good. Thank you so much. And I'm really looking forward to this hackathon and see how we can do with this wonderful ocean information model. Thank you to all.
Thank
Bye-bye.
you. Goodbye.
Thank you, everyone.
Bye-bye.
Bye.